Okay everyone, so I'm going to go through this example which is in the textbook. This pertains to the work we were doing on residual plots before the holidays. In another example we'll go through how to get those residual plots. That is something we've done together, but this example just starts with a scatter plot on the left here and a residual plot of that scatter plot on the right. Okay, so this example centers around fuel consumption of a truck carrying different load weights. So we would expect that an empty truck would use less fuel than a truck that's fully loaded because it's got more weight to carry. We're given the equation here. So F for fuel consumption is equal to 1.6 by W for weight plus 8.4. So that's been found for us. Here's the scatter plot. And here's the residual plot. So let's look at that residual plot and see if you can remember what features of this residual plot we're looking for to show that this is a good model for this equation, or a good model for this situation. Okay, so if you want to try that, go back through your notes and pause the video and go back through your notes and have a look at that. Then I'll go through that in a moment. Okay, so I'm going to go through the features of this residual plot that indicate this is a good model for the data. Okay, so first off, if we look at this residual plot on the right here, we see that there's a random distribution of points. So that's the first thing that we want to consider. I'll just get this one up a bit bigger. Okay, so random distribution of points. Okay, so these points are randomly scattered about. That's a good thing, that we want that. Okay, now the next thing to look for is that there's an even number of points above and below the line. Okay, so I'll do red points above. I think this one's just above the line. This one's obviously above, and so is this one. I think this one's just above, and so is this one and this one. That one there I'm not so sure of. I think he's right on the line. Okay, so in a different colour, I think that the ones below the line are in blue. These are all below the line. Okay, so above the line we've got 1, 2, 3, 4, 5, 6, and below we've got 1, 2, 3, 4, 5, 6 with one point that looks directly on the line. So we do have an even number of points above and below the line. So above and below the horizontal axis. So that's one of the other things we're looking for. So there's two conditions satisfied. Okay, now the next condition is an even horizontal band. So that means that we would draw horizontally the most extremely positive and the most extremely negative. And we see that the distance from the x-axis or the horizontal axis is about the same. Okay, so this distance from here to here is the same as this distance there. So an even horizontal band, it's not skewed upwards or downwards too much. So even horizontal band. Okay, so far 3 of the 4 things that we're looking for have been satisfied. Now the last thing we want to decide is, are the residuals small compared to the dependent variable? So we see that the dependent variable goes up to, from about, what's this, a bit below 10 to around about just below 20. And this residual here, which is 0.7, is one of the larger residuals. So I think that 0.7 is quite a small number compared to a range of 10 to 20. 0.7 compared to numbers up to 20 is a pretty small number. So we would say we've got small residuals. Okay, so here we have the 4 points that we're looking for. 1, 2, and 3, and the 4. Those things are the 4 things we look for to indicate that the residual plot, these 4 things, these 4 features of the residual plot indicate that this is a good model for the data. Okay, very good. So let's go on now to the next one in the opposite direction. Here we go. Right, so these are the type of questions that come up pretty frequently. We're told here that the point 2 and 12.3 is on the original data plot. There it is there. Interpret this in words. Okay, so this simply means 2 is the weight in tonnes, so 2 tonnes, and 12.3 is the litres per 100 kilometres of fuel consumption. So a truck that was carrying 2 tonnes it used 12.3 litres per 100 kilometres. So that's what that simply means. Okay, now, what fuel consumption would the equation predict for a load of this size? Well, if we look at our equation, there it is over there. Whoops, don't know what happened there. Let's see if I can just get rid of that. That's better. Okay, so we use the equation to make this prediction. All right, so fuel consumption. Here we've got that the weight, W, is 2 tonnes. So we're simply going to substitute that into our equation. F equals 1.6 by 2 plus 8.4, which gives us a fuel consumption of 11.6 litres per 100 kilometres. So this prediction is not what actually happened in real life. In real life, the truck that carried that weight used a little bit more fuel, actually used 12.3 litres per 100 kilometres. But remember, these predictions don't always match what happens in real life. They're just predictions from the equation. So there are some other factors involved sometimes. Right, so the residual. Now remember, residuals are actually the difference between the real life data points and the line of best fit. Okay, so if we want to find the residual value, we take the actual value. So in this case, that was 12.3. And we subtract the predicted value, which was 11.6. And that gives us 0.7. Now, magically, that matches that residual point up there. That is the residual point for this one, for that scatter plot point there, or that data point. So, what does this mean? Okay, so this is a frequently asked question. They'll tell you a point 2 and 0.7 is on the residuals graph. There it is there. What does this mean? Interpret it in words. So this simply means, well, actually I'll let you think about this for a moment first, but it's all about how does the actual value compare to what was predicted. So in this case, is the actual value greater than or less than what was predicted? And the actual value is greater. What we find is that in real life, the truck used 0.7 litres of fuel more than what was predicted by the equation. So we could interpret it like this. A truck that carried 2 tonnes used 0.7 litres per 100 kilometres more than what was predicted by the equation. Okay, so this line of questioning down here is frequently used in tests and exams. So make sure that you practice these types of questions from the textbook and be able to understand how to do those ones. Okay, everyone, so I'll be back soon, and you guys should try that one. Try those questions that have been set out and also the ones on the assignment.